So taking a look at our symmetry test, the y-axis was number 2, right? So what I'm going to do is I'm going to replace r theta with negative r and negative theta. So if I did that, what would my equation become? So we're going to use the symmetry test that says replace r theta with negative r, negative theta. So what would my new equation be then? Negative r equals 4 sine of negative theta. Then we're going to use the fact that the function is either even or odd and try to simplify it. So what we're trying to show is if one of these tests work, when you do that, you're going to be able to show using properties that we can get back to the original function. So 4 sine of negative theta, sine is odd, so how could I rewrite that? Negative sine of theta, right? So I'm going to just pull that all the way to the front. Okay. And then what could I do? Divide both sides by negative 1. Okay, so I'm going to put a little check mark there because look back at the original. When I did my symmetry test, I got back to the original function. Let's just take a look at what this looks like a minute. So I'm going to take a look at 4 sine theta and just look and see once it's graphed that it has y-axis symmetry. And I'm going to make sure I'm in radian mode, which I'm not. And when I'm in radian mode, I do my theta is 0 to 2 pi because that will give me 1 full rotation. Okay. Does that have y-axis symmetry? It does. Yep. This is actually a circle. All right. Do you want me to show you what x-axis looks like? Okay, let's do an x-axis one. Okay, we're going to use the symmetry test to prove that r equals 1 plus 2 cosine theta has x-axis symmetry. Okay, so what's the test for that? Look it up. We replace r theta with r negative theta. So now when we are doing this equation, we are not going to make the r negative, we're just going to make the theta negative and see what happens. So our new function then would be r equals 1 plus 2 cosine of negative theta. What can I do with 2 cosine negative theta? Yeah, and if I ever asked you, why did you do that? I mean, let's write y. I'm going to write cosine is even, which is there, so we know that. Cosine is an even function. That's how we can do that. Alright, and so then that's kind of just a one-stepper. Then we're back to the original, and so we just showed that this should have x-axis symmetry. Let's graph it and see. There's no catch. Ooh. Okay, so this is actually, this is called a Limousin curve. So you're going to see tomorrow, we're going to take more time to study these. But a Limousin curve actually can have several things go on. This one's called an inner loop. Did you notice when you graphed it, like it looped in the inside? Okay. Apparently the word Limousin, and I don't know, we don't have French here anymore, right? But so, but when Miss Duncan was here, we had, you know, French could be a foreign language, but the word limaçon is actually Old French, which so must be derived from something else. But for snail, and so what these kind of are supposed to look like are, do you know what a snail looks like? Okay, like shell, almost like a shell, kind of where it's oblong. Some of them do this. Some of them actually don't go in all the way. They kind of like just, one's called a cardioid actually because it looks like a heart shaped almost. And then some are just called convex, so they just kind of flatten out. And so we'll look at when the, you know, which do what and why. Okay, so how are we doing so far? Then we should talk about one more thing, and that is our max values, okay? Because when you're graphing something in polar mode, analyzing polar graphs, we're really not going to analyze quite in the way that we did earlier in the year. One of the nice things about polar graphs is I give you, they kind of follow patterns, and so you're going to be using these patterns tomorrow when we do this. The analyzing really is laid out for you depending on what numbers are in the function. But one thing that we've never studied before is something called an R-max. And so I'm going to draw a rose curve a second. And so I'm going to draw a rose curve with 3 petals. Okay. Oh boy. Alright. So the R-max, and this is polar, this would be in polar mode. The R-max would be this distance here. Okay, this is called the R-max. What do you think the R-max, think about that word. What do you think that is? Yeah, the R-max is the maximum R value the function ever attains. So I'm going to just quick show you this graph in a minute. You see it. It's this graph. I'll just put it up so you can see 4 sine 3 theta. Okay. There you go. That's better. All right. So remember that we have a rectangular screen. So how many times does it look like the curve gets that R-max, that furthest away? Well, here, here, and down there, 3 spots. Okay. Now here's the thing. If I said, what is the R-max? I want you to just think about something. Think about what the graph of this is in function mode. Can somebody tell me what their guess is? How far? What's the R-max? What's the maximum distance? A number. 4. Hey, think of it in... Yeah, isn't it the same as its amplitude? It's just graphed... When this is graphed in polar mode, it looks like a flower. When it's graphed in function mode, it looks like a sine or cosine curve. Alright, so we can find the R-max by taking the absolute value of that number. Okay? And you're going to notice on that formula sheet, doesn't it say for a rose curve and the other one, max R value? Do you see it says absolute value of A on there? Okay. All right. Here's the tricky part. How do you find theta? Because theta is how far it's rotated. Okay, if you had to guess, let's say if you had to guess for this one, what do you think those angles would be?
Are they evenly?
I don't know. It's hard to tell, isn't it? because it could be maybe like 45 and, or pi fourths, right, and one's, okay. Or couldn't it maybe be, think about this, if you divided 360 into thirds, they could all be 120. Now, if you go to trace or go to calc, crap, that doesn't help me. There's no R max key. Okay? Shoot. What's another way do you think that you could figure out those angles? Okay, let's go back to what I said. The amplitude is the R max. Can't I find maxes in function mode?
Wait a minute. No way. You're not going to change.
If you could go back to function mode and find where it hits its max, that's going to be the same spot where it hits its R max in a polar mode. Okay. It's not cheating. It's the only way to do it. All right. So let's just graph it a second. And what I'm going to tell you is to find, so we know this, where R maxes occur, graph in function mode.
Oh my gosh.
Okay. So let's figure it out. So let's switch our mode. Let's go back to function mode. Now remember, we don't have a theta in function mode, and that's why the theta is going to be on the x-axis. What was it again? 4 sine 3x. Okay. To make it easier, I'm going to go 0 to 2 pi. You remember when I did this? And I'm going to make my scale pi halves so that I can see the tick marks. And then -5 to 5 should be good. Okay, and so then when I'm looking at this, it looks to me, so this is pi halves, right? Okay. So what does it look like to you, where they occur? Well, isn't this the maximum away? And then this is another one. And this, and this, and this, and this. Actually, what happens is it hits it, and then it hits it again. So the first three, those are the R max values. All right, let's break it up. In those two rows over there, would you guys find this first one? Tell me what it is. And the middle two, you guys are finding this second one. This is still a max because it's still the furthest distance away. And then you guys are going to find this third one. Okay, now, if these were exact, we could try to figure out what they were. Does that make sense? Okay, I just wrote down theta instead of x. I wrote down the first three. Couldn't I try to figure out what these numbers are? Like, I think that's Okay. You think it's 5/4? Oh no.
No. Put in 5/4 for gas.
Look what it is though. Yeah. So the only way to really tell for certain, like if they were exact ones, would be to like type in their value and see. What do you think that one is? Well, I know it's past pi, right?
5/4.
She's calling 5/4. It's too big.
Try 3/4. Oh, that's it. God.
All right. But